Hello everyone! Today we'll introduce an embodied intelligent robot that integrates AI large model technology, ROSMASTER M1. It adopts Mecanum wheel motion chassis, equipped with language large model, voice large model, and visual large model, possessing the ability for free dialogue and environmental understanding. It can also perform embodied intelligence tasks such as slam map object search, inspection, and autonomous driving. Let's start experiencing it now. Here are all the components of the M1. Two versions are available: standard version and superior version. Compatible with RDK X5, Raspberry Pi 5, Jetson Nano, and Jetson Orin Nano 8GB. The main differences between the versions are the camera and LiDAR. Standard version comes with 2MP HD camera, PTZ, and T-Mini Plus LiDAR. Superior version comes with depth camera and T-Mini Plus LiDAR, 2MP HD camera PTZ, T-Mini Plus LiDAR. All versions offer an AI large model voice module, supporting voice interactions and large model functions. About main control board: standard version port Raspberry Pi, RDK X5, Jetson Nano. Superior version support Raspberry Pi, RDK X5, Jetson Nano, and Jetson Orin Nano 8GB. Different main control board are consistent in terms of course materials, control software, and functional experience. Now we're introducing the Jetson Orin Nano 8GB superior version. The vehicle body and extension plates have been pre-assembled. Users only need to assemble the LiDAR, camera, main control board, and other components to complete the assembly. Adopt Mecanum wheel chassis design, equipped with 520 high-torque encoder metal motors. Supports 360-degree omnidirectional movement. It possesses excellent agility and maneuverability. The chassis is made entirely of aluminum alloy, making it robust and durable, with ROSMASTER control board optimized for ROS systems. This is the instruction manual. It contains detailed assembly and usage steps. This is Jetson Orin control board. This is the depth camera, equipped with an 3D structured light depth camera. The depth measurement range is up to 4 meters, can accurately calculate the distance and volume information of objects. This is the camera bracket. It supports adjusting the camera angle. USB hub board. It can be used to expand USB ports. T-Mini Plus LiDAR. Sampling frequency is 4,000 times per second. Measurement radius is 12 meters. It can realize various functions such as mapping, navigation, and obstacle avoidance. AI large model voice module integrates a high-sensitivity microphone and cavity speaker. It not only has the ability to clearly recognize speech. USB handle can control robot car. Battery and charger: 12 6V6000 mAh lithium battery pack. Larger capacity, longer working time. Screws, screwdriver, and accessory package. Next, let's start assembling. The car is now assembled. Let's experience its functions. Language large model, voice large model, visual large model by deeply integrating multimodal, large modal, and dual model inference architectures, M1 is able to understand its environment, plan its actions, and execute tasks flexibly.
Hi, Yahboom.
I'm here.
Describe the signs you see.
I see a green fenced area with several black and white cows and sheep inside, and a tree and a small pavilion nearby.
By combining large AI model with SLAM technology, robot car can deeply understand the spatial layout of objects in different areas of a map, and can even perform search tasks for specific objects within the map based on the user voice commands.
Hi, Yahboom.
I'm here.
Help me find my mobile phone.
Okay, I'm going to the dormitory building to look for it. I didn't find your phone in the dormitory building. I found your phone in the teaching building.
It can also perform complex, long instruction tasks.
Hi, Yahboom.
I'm here.
Move forward 1 meter, backward 15 cm. Move 20 cm to the right. Move 14 cm to the left. Move 30 cm clockwise at a 45 angle. Finally, simulate song and dance.
Okay. All the moves are done. Now I'll sing you a song and dance. Even anticipate intentions, independently understand user potential needs, independently plan and respond to tasks.
Hi, Yahboom.
I'm here.
I'm hungry.
I'm navigating to a restaurant now. I found apples, bananas, and potato chips at the restaurant. Let's enjoy it together.
The M1 can also be used with scenario-based autonomous driving maps to recreate real-world road environments, enabling traditional vision-based autonomous driving applications, such as autonomous parking, steering decision-making, and traffic light recognition, providing an immersive autonomous driving experience. By integrating AI multimodal large model, visual autonomous driving model, and ROS2 road network planning system, M1 can understand voice commands, autonomously plan the optimal path based on the road network, and recognize road signs on the sand table in real time, bringing a more intelligent autonomous driving experience.
Hi, Yahboom.
I'm here.
Navigate to the hardware store to pick up the goods. Then, deliver them to the construction site. Please obey the traffic rules while driving.
Okay, I'll go into the hardware store. The goods have been loaded and are ready to depart for the construction site. Goods safely delivered to the construction site. Task is completed.
Regarding large model functions, Yahboom have implemented for core innovations, innovatively adopting a dual model inference architecture, integrating dynamic feedback inference, and allowing flexible expansion of the RAG knowledge base, significantly improving the ability to understand contextual relationships and recognize user intent, also supporting free-flowing dialogue interruption function, achieving a more natural and efficient interactive experience. Beyond its powerful AI large model functions, M1 also supports extensive ROS functions, combined with relocation and navigation solutions, effectively reducing location drift, supports single-point navigation, multi-point navigation, and dynamic obstacle avoidance. Equipped with a 3D structured light depth camera, can generate depth images and point cloud data in real time, enabling distance and volume measurements. Combined with LiDAR, it can construct high-precision 3D color maps, achieving more accurate environmental perception and intelligent navigation. Through the media pipe framework, it can recognize facial contours, limb frames, human features, and fingertip trajectories, thereby enabling visual interaction applications such as visual control and target tracking. With high-performance YOLOV11 deep learning model, supporting the running of default models such as force segmentation, and can be flexibly extended to train custom models, employing the KCF target tracking algorithm, combined with the distance perception capabilities of depth camera. It enables 3D following with spatial distance awareness. supports multi-robot navigation on a single map and dynamic obstacle avoidance, achieves multi-robot, synchronous control and platooning performance. Yahboom will provide course materials covering applications of depth cameras, LiDAR, SLAM, AI large model, comprehensive teaching courses and experimental cases. In summary, M1 not only continues the mature application of traditional robots within the ROS ecosystem, but also achieves significant functional expansion. It not only supports large model interactive functions, but also integrates autonomous driving functions and innovatively deeply integrates AI large model with traditional autonomous driving systems and ROS to road network planning, significantly enhancing the robot intelligence. With its omnidirectional Mecanum wheel chassis, the M1 possesses exceptional flexibility and responsiveness, suitable for a variety of application scenarios, such as university lab teaching, autonomous driving algorithm verification, and large model application development.